Unit 9B, Binomial Distributions. A binomial game, or a binomial experiment, has the following properties. The game is going to be repeated a certain number of times. These are called trials. And the symbol we're going to use for the number of times the game is going to be repeated is n. Each trial has exactly 2 outcomes. For example, the game could be flip a coin. If you flip a coin, then the 2 outcomes are head and tail. Now, these 2 outcomes, one of them is called success, and whichever one is called success, then the other one is called failure. Or it could be have a baby. When you have a baby, there are 2 outcomes. The baby is a boy or a girl. One of them is success, one is failure. Now, the choice really doesn't matter, but it makes things easier if you let success mean the quantity you're looking for or the outcome you're looking for. So if you're looking for girls, then we call girls success in this case, and the boys would be failure. Or you could say the game is guess the answer to a 4-option multiple choice question. Well, when you guess the answer, you either get it right or wrong. Now, your first inclination might be to call getting it right success. However, if you're interested in the number of questions you're going to be getting wrong, then you would call wrong success, and then right would be failure. So success doesn't mean good. Success means what you're looking for. Now, the probability of success is indicated by the letter P, and the probability of failure is Q. So P goes with success, Q goes with failure. P goes with success, Q with failure, P goes with success, and Q goes with failure. So, for example, flipping a coin, the probability of success would be, probability of getting a head would be 1/2. When you have a baby, the probability of having a girl also 1/2. If you're guessing the answer to, let's say, a 4-part multiple choice question, 3 of those parts are wrong, then the probability of getting it wrong would be 3 out of 4. The probability of failure would be 1/2 here, 1/2 here, and 1/4 here. If you notice, in every case, P plus Q always equals 1. The number of successes you're looking for in the n repetitions is indicated by the letter X. Suppose a certain type of treatment for patients suffering from vertigo works 20% of the time. What is the probability that this treatment will work on exactly 3 of 5 randomly selected patients suffering from vertigo? I would suggest writing down what the binomial game is that we're going to be repeating. Now, the binomial game is going to be treat 1 patient for vertigo. Now, is this a binomial game? Does it have 2 outcomes? Yes, it does. The 2 outcomes are the treatment works or it does not work. Now we're going to call one of these success and one of these failure. Now, what are we looking for here? We're looking for what is the probability that the treatment will work 3 times out of 5. So we're going to call work success. That means not work is failure. And that also says, therefore, P always goes with success, and Q goes with failure. Now, since it says the treatment works 20% of the time, that means the probability of success is 20%. We usually write this as a decimal. And therefore, it does not work 80% of the time. So Q would be 0.80. These two always add up to 1. Finally, we have to get the number of times that the game is going to be repeated. So it says here we want to get 5 patients, so we're going to repeat treating the patient 5 times. And X is the number of successes we're looking for. We're looking for 3 successes. So we have found these 4 values, and with those 4 values we can solve the problem either by a table in the book, using the binomial formula, or using the TI calculator, which has a built-in function. It's called the binomial PDF function. So any one of these 3 methods can be employed. First of all, using the binomial distribution table, N is the number of repetitions. We see that N is 5. So we go down this column to 5. Now this table says R. I like to use X instead of R. X is 3, the number of successes. So from the 5, we go down to 3. The next thing we need is P. The probability of success is 20%, and the P values are across this top row, and P is 20% is here. Now, where the column for 20% and the row for 3 meet, that's the answer to this problem. So it's going to be 0.051. That's 5.1% is the probability that you'd have 3 out of 5 successes. We could also use the binomial formula. The binomial formula says the probability that X equals 3 would be NCX, that's 5C3, times P to the X 0.20 to the X power, X is 3. Then we have Q 0.80 to the N minus X. N minus X would be 5 minus 3, or 2. Now, you could do this by hand. 5C3 is 5 factorial over 3 factorial, and then 5 minus 3 factorial is 2 factorial. So this is 5, 4, 3, 2, 1 over 3, 2, 1 times 2 times 1. A lot of cancellation takes place. And 2 into 4 goes 2, and 5 times 2 is 10. So you could do it by hand, or you might want to do this on the calculator. on the calculator, oh, and by the way, you could do 0.20 by hand. That's 0.20 times 0.20 times 0.20, and then times 0.80 times 0.80. Well, most people probably would rather use the calculator. On the TI-84, you would press 5, and then math, then probability. Then you would choose from a menu the NCR option, and then put in the 3, and press enter, and that would give you this number 10. Then you would key in 0.20 or 0.2, then use the exponentiation key, which is the caret key, then 3, and then enter. That would give you 0.20 cubed, and then you could do 0.80 or 0.8, and you could do caret 2, or you could use the x squared key, either way, and do that, and you get each of these 3 pieces, multiply them together, and get the answer. Or that's doing it in pieces. Or you could press this first part, hit times, press this next part, hit times, and then press enter at the end. And that's probably easier. And that should give you the same result as before, the 0.051. Finally, we could do this on the TI calculator using the binomial PDF function, and that's second distribution, and then pick binomial PDF. You'll have to scroll down a ways in your menu. You won't see it at first, so keep scrolling down till you see binomial PDF. Be careful, don't use the cumulative density function, the CDF. We want the PDF, which in my calculator was letter A. Then we press enter, and you fill in N is 5, P is 0.20, and the X value is 3. Navigate down to paste, hit enter, and there's the answer. The same answer we got before with the other methods. End of Unit 9B.